You can cut the city with one straight line and cut both its parts precisely in half by area. Let's prove it. Consider a function f that maps any partition of the city bordered by a line to the amounts of each part it contains as a coordinate in 2D space. It turns out that the space of all straight 2D lines combined with the binary choice of side is topologically equivalent to the sphere, because there exists this continuous bijection between them, which constructs a point's perpendicular plane and pairs it with the line where both planes intersect. According to the Borsuk-Ulam theorem, any continuous map of the sphere to the 2D plane has an opposite pair of points ending up on the same spot. We can prove this using a function g that returns the difference between a point's output and its opposite's output. Mapping the sphere's equator in g's input space must result in a loop around 0 in its output space because its second half is opposite the first. When the circle moves upwards along the sphere, the output loop must contract into a single point and therefore necessarily intersect 0. In our mapping, opposite points on the sphere correspond to opposite partitions of our city bordered by the same line. On the basis of Borsuk-Ulam theorem, two opposite partitions must therefore have the same output when applying our function f, or in other words, must contain equal landmass of both parts. Borsuk-Ulam applies in all dimensions, and our conclusion can thus transfer over into objects of all higher dimensions, like a marble cake. For all the quarrelsome siblings out there, this is the marble cake theorem.